how prefabricated bridges are revolutionizing construction. What if I told you we could build a bridge in just a few days instead of months? Sounds like science fiction, right? Well, welcome to the future. Prefabricated bridge technology is changing the game, making construction faster, smarter, and more efficient than ever before. What is prefabrication in bridge construction? Before diving into its applications, let's first understand what prefabrication actually means. Prefabrication refers to the process of manufacturing structural components of a bridge off-site in a controlled environment. These components, such as beams, girders, decks, and piers, are then transported to the construction site for quick and efficient assembly. This method differs from traditional construction, where every part of the bridge is built on-site from scratch, which can be time-consuming and susceptible to environmental delays. Types of prefabricated bridge components. Prefabricated bridges rely on different types of structural components, depending on the design and load requirements. Some of the most common prefabricated bridge elements include T-girders, a widely used type of prefabricated beam with a T-shaped cross-section, providing strength and ease of installation. Box girders, hollow rectangular girders used for long-span bridges, offering high torsional resistance and stability. I-girders, similar to T-girders but with a distinct I-shape, commonly used in highway overpasses and railway bridges. 2 segmental precast elements, modular sections designed for quick assembly, often used in long-span bridges and viaducts. 3. Precast deck panels, ready-made slabs forming the bridge deck, reducing the need for extensive on-site casting. Each of these components plays a crucial role in making prefabricated bridge construction not only possible, but also highly efficient and durable. Before we go further, make sure to like this video and subscribe to Highway and Bridge Insights for more fascinating engineering content. A historical perspective on prefabricated bridges. Did you know that the idea of prefabrication isn't new? It dates back to the 19th century. One of the earliest examples is the Bailey Bridge, developed during World War II. These modular steel bridges were a game-changer for military engineers, allowing them to quickly assemble and deploy bridges across rivers and battlefields. Fast forward to today, and we see prefabrication taking infrastructure development to the next level. How prefabrication is transforming bridge construction worldwide. Around the world, countries are embracing prefabrication to build bridges at record speeds. In the United States, the Accelerated Bridge Construction (ABC) program has helped replace entire bridges over a single weekend. Yes, a weekend. One example is the I-95 Bridge Replacement Project in Miami, completed in just 48 hours. Imagine waking up to a brand new bridge overnight. China, on the other hand, is the king of speed. Prefabrication is a crucial part of their high-speed rail network, allowing them to construct massive bridges in a matter of weeks. The Beipanjiang Bridge, one of the highest bridges in the world, was built using modular components, making it both faster and safer. And in Sweden, the Stockholm Bypass project has demonstrated how prefabricated bridge sections can keep traffic moving while major infrastructure is being built. It's all about efficiency. Even Japan, a country known for its earthquake resilience, has incorporated prefabrication into seismic-proof bridge designs. The Shudo Expressway Viaduct project in Tokyo uses modular bridge sections specifically engineered to withstand earthquakes. That's innovation at its finest. Prefabricated bridge construction in Africa. Africa, too, is seeing a surge in prefabricated bridge construction as governments push for faster, cost-effective, and durable infrastructure solutions. In Kenya, the Nairobi Expressway incorporated prefabricated bridge components, significantly reducing construction time and minimizing traffic congestion in one of the busiest cities in East Africa. Nigeria has also embraced prefabrication with projects such as the Second Niger Bridge, which uses modular elements to accelerate construction and improve connectivity between different regions. This project is a key part of Nigeria's infrastructure transformation plan. In South Africa, prefabricated elements were used in the Gauteng Freeway Improvement Project, ensuring minimal disruption to daily traffic while enhancing transport efficiency. Similarly, in Tanzania, prefabricated concrete beams have been instrumental in the construction of bridges along major corridors like the Dar es Salaam Bus Rapid Transit (BRT) system. If you're amazed by these engineering marvels, hit that like button and drop a comment below. Which country's approach do you find the most impressive? Ethiopia's experience with prefabricated bridge construction. Now, let's bring it home to Ethiopia. Prefabricated bridge construction is making a real impact here. One of the biggest examples is the Addis Ababa Adama Majo Hawassa Expressway, a critical highway connecting Addis Ababa with the southern regions. Thanks to prefabrication, construction was faster, safer, and more cost-effective, reducing delays and improving trade routes. And what about Addis Ababa? The city's major flyovers, including Gotera, Imperial, Lebu area interchanges, have utilized prefabricated elements to minimize congestion. Imagine the chaos if these bridges were built traditionally. It would have taken years. Prefabrication made it possible to cut construction time in half while keeping the city moving.
I got a chance to participate in both Imperial and Lebu overpass bridge design and construction projects. And from this project, I observed that the impact of using prefabricated beam in the bridge construction in both projects is very highly advantageous. And in both projects, post-tension precast box girder beam were utilized, which provide a number of advantage over that of the normal structural cast in situ beams. And using the precast beam greatly improved the construction efficiency and reduce project timelines. Since these beams are manufactured outside of the site, they can be produced simultaneously with the preparation, so leads to a more streamlined construction process. And this approach minimizes the delay caused by the traffic, as well as the installation of the precast beam can complete quickly and allow the fastening of the project for all. And in those projects, I witnessed that how those benefits translated into time saving and increasing overall efficiency. And the using of the precast beam not only enhances the speed of the construction, but also improves safety on the site by reducing the need for extensive formwork and the pouring of the concrete on the site, which can often lead to the complication. And after all, the decision to use the post-tensioning precast box girder beams for both projects was a key factor.
The future of prefabricated bridge construction. And here's where it gets even more exciting. The future of bridge construction could soon involve 3D printing, robotic assembly, and AI-driven design. Imagine entire bridges being printed layer by layer with minimal labor. Prefabrication is just the beginning of a massive transformation in global infrastructure. Now it's your turn. What do you think? Should Ethiopia invest more in prefabricated bridge technology? Let's start a discussion in the comments. If you loved this video, make sure to like this video, comment your thoughts below, subscribe for more infrastructure insights.